Here's some selected problems from section 3.2. We're finding derivatives here. So first we have the derivative of 2e to the x plus x squared. So you take the derivative of 2e to the x, which is a constant, times e to the x, which is a constant times the derivative. The derivative of x squared is 2x. The derivative of e to the x is e to the x. So that's the solution. Number 9, we have 2 to the x plus 2 over x cubed. Derivative of 2 to the x is log 2 to the x. And then I'm just writing down the derivative of 2 over x cubed because I want to write it down as 2x to the negative 3. Then I just copy this down. The derivative of 2x to the negative 3 is negative 6x to the negative 4. So here's your solution for that one. Over here 19, it's an interesting one. It's e to the pi plus pi to the x. E to the pi is a constant. It does not have an x in it. Derivative of a constant is 0. Pi is a number. We know the derivative of a number to x is log of the number times the number to the x power. So that's all there is to that one. Then number 39, we have a population in 1960 is 35,000, 0.98 to the t. 0.98 is a decay, so it's a decay factor, so the population is dropping, so we expect there to be a negative derivative for the population. So they say find the population rate of change in 1983. That's 23 years after 1960. So we compute a derivative. The derivative of a constant times a function is constant out in the front. Derivative of 0.98 to the t is log 0.98 times 0.98 to the t. We plug in the 23 right here, evaluate it out, and you get negative 440.3. So about negative 444 people per year. So the town is losing 444 people per year in the year 1983. So that matches up with what we thought, that it was a decay function, so that the derivative should be negative. And it was.